Once upon a time, long before humans roamed the earth, there existed a planet shrouded in chaos and molten rock. This young world was devoid of one crucial element that would later become essential for life as we know it, the atmosphere. The story of how air came into being is a tale of cosmic evolution, involving the birth of stars, the formation of planets, and the emergence of the very elements that make up our Earth's gaseous envelope. The origin of air can be traced back to the early universe. In the aftermath of the Big Bang, only the lightest and simplest elements, like hydrogen and helium, were created. These primordial elements formed the first stars. Through the process of nuclear fusion, stars produced heavier elements by fusing hydrogen atoms together. Eventually, massive stars reached the end of their lives and exploded in cataclysmic supernovas, releasing vast amounts of energy and matter into the cosmos. These explosive events scattered the newly formed elements, including oxygen and nitrogen, into space. Over time, these elements came together in vast clouds of gas and dust, known as molecular clouds, under the influence of gravity. As they congregated, these clouds began to collapse, leading to the formation of protostars. Within these protostars, the intense heat and pressure triggered nuclear fusion, creating new stars and planetary systems. In our solar system, one such star formed the Sun, and around it, the planets, including Earth. As Earth formed, it began as a molten sphere, devoid of an atmosphere. But air was already in the making. Water, too, played a vital role in this grand narrative. Earth was bombarded by comets and asteroids, delivering vast quantities of water, which began to accumulate on the surface. Over millions of years, this water vapor evaporated and condensed, forming the Earth's first oceans. The water cycle became a fundamental part of the story of air. As water evaporated from the Earth's surface, it rose into the sky as water vapor. As it ascended, it encountered cooler temperatures at higher altitudes, causing it to condense into tiny water droplets, forming clouds. The relentless cycle of evaporation, condensation, and precipitation became the engine of weather systems and a critical player in the formation and maintenance of Earth's atmosphere. Air pressure, another vital component of this story, is a direct consequence of the atmosphere's existence. As Earth's atmosphere took shape, it became a blanket of gases surrounding the planet. The weight of the air above exerts pressure on the surface, and this pressure varies with altitude. Air pressure plays a pivotal role in controlling weather patterns and creating the winds. Wind energy, too, has its origins in this celestial narrative. The Sun, as a massive fusion reactor, emits a continuous stream of energy in the form of sunlight. This energy interacts with Earth's atmosphere, heating different regions unevenly. Hot air rises and creates areas of low pressure, while cooler air sinks, generating areas of high pressure. The movement of air from high-pressure areas to low-pressure areas creates wind. Wind, in turn, carries energy, spreads moisture, and influences the Earth's climate and weather. The formation of Earth's atmosphere, its interplay with the water cycle, air pressure, and wind energy, and the role of cosmic processes in shaping our world are all part of the grand scientific story of how air came into being. This narrative, woven from the fabric of the universe itself, continues to evolve and shape our planet's environment, sustaining life as we know it. Science helps us understand and appreciate this magnificent tale of Earth's atmosphere, connecting us to the cosmos from which it ultimately emerged. Ever wondered why that gentle breeze feels so soothing, or why a gust of wind can be so destructive? Well, the answer lies in the fascinating world of wind, a natural phenomenon we often take for granted. Today, we'll dive into the science of wind, its various kinds, and how we measure it. So, sit back, relax, and let the winds of knowledge blow your way. Wind is, in essence, the movement of air from an area of high pressure to an area of low pressure. This movement is primarily driven by the uneven heating of the Earth's surface by the Sun. When the Sun's rays heat the ground, the air above it also warms up and begins to rise. This creates an area of low pressure below, and cooler, denser air rushes in to fill that space, creating what we perceive as wind. Winds can be classified into three main types based on their scale. The first is the global winds. These are the planet's most extensive wind systems, and they occur at specific latitudes. They include the trade winds, the westerlies, and the polar easterlies. The second type is the local winds, which are influenced by geographical features like mountains, valleys, and bodies of water. They include sea breezes and land breezes. Lastly, we have the monsoon winds, which are seasonally reversing wind systems associated with the yearly cycle of changing temperature. Now, how do we measure wind? Wind speed is often measured using an instrument called an anemometer, while wind direction is determined using a weather vane. To measure the speed of high-altitude winds, meteorologists use weather balloons equipped with radiosondes. Wind interacts with everything it touches. It can erode mountains, shape sand dunes, and even help pollinate plants. On water, wind creates waves and currents, and on a larger scale, it influences global weather patterns and climate. Wind plays a crucial role in the formation of severe weather phenomena like tornadoes, tsunamis, and storms. For instance, tornadoes form when different wind speeds and directions at different heights cause the air to rotate. Wind is also an essential part of the water cycle. It helps to evaporate water from the Earth's surface, transports the moist air, and helps form clouds. When these clouds reach cooler areas, the water vapor condenses and falls back to the Earth as precipitation. In conclusion, wind is a vital part of our planet's climate system. It is a product of the Earth's rotation and the uneven heating of its surface, and it comes in various types, each with its characteristics and effects. We measure wind using various tools, and its interactions with its surroundings can be both beneficial and destructive. It's a fascinating, ever-present force that shapes our world in many ways. So, the next time you feel a gust of wind, remember, it's not just air moving around. It's a complex, powerful phenomenon that's been shaping our planet for billions of years. It's a testament to the dynamism of our world and a reminder of the intricate interplay of forces that make up our environment.